My name is Santiago Suarez Ordóñez. I work at SOS. I help writing a lot of our own Selenium tests, as well as every developer at the company does. And we've been doing this for over 2 years now. We have a pretty long test suite. We have, if I recall correctly, at least 250 Selenium tests and at least over 600 regular tests, including unit tests, functional tests, and all sorts of stuff. And we've fought with flaky tests for a long time. When you start collecting large numbers of tests, things start randomly failing and making your build red all the time. The problem for us is that we would never deploy any commit that would make a build red. So we really trust our build. And if the build is red because of a flaky test and not because of a broken functionality, developers stop believing in the build and start hating the process of having to wait for some random behavior to tell them whether their changes are valid or not. So we started fighting these flaky tests with all we could. Most of the times they were Selenium ones, and it's worth pointing out that Selenium is driving a real browser through a web page, and that's the highest level you can test your application at, but it's also the most complicated one. A browser is a pretty complicated technology. There's a lot of stacks. There's a JavaScript compiler, there's the OS level execution runtime. There's a lot of things going on, and there are a lot of things that could go wrong. So to be able to make those tests as robust as possible, there's a lot of things you got to be prepared to tackle in advance. So let's just get started. This is the list I took from our own test harness. Probably a lot of things could be added, and maybe some of this could be removed. But this is a real world example, so you just let me know if you agree or disagree with any of this. So number one, I feel it's the most important one, are implicit weights. Nowadays, applications are moving towards Ajax and JavaScript-based UIs in almost every case. Selenium is a bot and moves way faster than a human being. So as soon as it opens a page, it will start trying to interact with its elements in less than a millisecond or something. It will just be super fast, trying to click around stuff, filling out fields. And the problem with the applications of today is that if they use something like jQuery UI or UE, or they just try to load elements through Ajax, is that they will look pretty instantaneous for real human beings, because they will take, let's say, 1 or 2 seconds to render the whole UI. But for the robot, that's really slow. Selenium will just try to interact with those elements way before they are rendering the UI and ready for you to interact with them. So something that is really, really handy to write your test with are implicit weights. This feature is actually already part of Selenium 2, and that is awesome. But for Selenium 1, you will have to code some custom solution for yourself. So I'm going to show you how we did it at Sauce Labs. I'm going to show you Python code. I think it's pretty readable, even if you don't know Python at all. And it should probably give you a good idea of how you should do it when you do something like Java or PHP or Ruby or whatever. So this is our own Selenium extension. It inherits from the regular Selenium. As you can see here, we import Selenium from Selenium. In Java, that would be default Selenium. So we extend that class And basically what we add is a value called implicit weight that we set to different, that we set to 30 right now. Sorry. And basically we are plugging our functionality to the do command action that Selenium has. This is basically a method that is called for every single command that is sent to the Selenium RC server. So basically what we're doing is trying to run the default do command, and if we detect that there's an exception saying that an element wasn't found, what we do is just sleep for a second and try again until we reach the 30 seconds that we've defined as implicit wait. So basically, every time you try to do a click, every time you try to do a type, every time you try to interact with an element, if the first time works, you're good to go, nothing will change. But if the first time or the second one, or during the first 30 seconds in this case, you get that the element wasn't found, Selenium will just retry to do that action. And it's unbelievable how much this has changed the flakiness in our test suite. It's pretty crazy to see all the reasons for which an element may not be already rendered in a page by the time Selenium tries to interact with it. But just by making Selenium retry over 30 seconds, it's going to make a huge difference, and it's just going to turn your flakiness ratio from 90% to probably like 20 or 30%, which is crazy. So that's definitely my main advice. Try to start waiting for elements to be present every time you try to interact with them. Even if you run the test 10 times and those 10 times it just works, when you start running a build on every commit, you will be running your test thousands of times. And if you have 1,000 tests, we're talking about a lot of chances of this to fail. So just incorporate that to your own suite. I'm probably going to be publishing this class and some of the features I'm talking about here in a blog post. So stay tuned. You just go to saucelabs.com/blog, and probably something will come out there soon. Now, another tip, use reasonable timeouts. What are timeouts in Selenium and what are they used for? Well, timeouts are used for when Selenium tries to open a page or to wait for the page to load. Every time you run an open, Selenium will wait for this specified amount of time. You can define the timeout on per command basis. So, for example, you can call, let me just write it down here. You could just call something like selenium.open saucelabs.com and wait for 90,000 milliseconds. Yeah, that's unreadable, but that's how the project chose it. So you can specify this, or you can just call open, and Selenium will use the default timeout. And that default timeout is handled using selenium.setTimeout, which by default, sadly, is 30 seconds. So why do I think 30 seconds is not a good idea? Well, most of us are running tests over development environments or test servers. These servers are generally not as robust as the production ones, and most of the times, and even more so if you're using Sauce on demand, you could be running your tests in parallel, causing an inherent load on your server. So if your server gets 30 requests from 30 real browsers at the same time, it may take it a little bit longer to reply to each. So why do we really need to specify such a short amount of time? If we could just tell it to wait 90, and it's not going to change the performance in our tests at all. It's just going to make some of them pass even if the load is high during this time. So in this case, if the page completes loading in 5 seconds, you don't really need to wait for those 90 to complete. Selenium will detect it and just move on. The only difference is that if your server or your application needs a little bit longer to load, the test will not fail, and you'll get the result anyways, even if it takes 60 seconds, which is still reasonable under development or testing conditions. So definitely set timeouts to over 90 seconds. Now, this is an awesome advice. It's not always easy to implement, but it's definitely worth mentioning. So it says generate application states with test handles. What does that mean? Well, when you run Selenium tests, you are emulating a real user. So people have this tendency to do exactly what the user would do in the whole workflow. So if they have to test something like a shopping cart, for example, they will start their test by logging into the application, then going to search for some kind of element, some kind of item they want to buy, then add it to the cart, then check out, and then complete the whole sale. Well, that's a totally valid test, but it's terribly long, and it's going through all sorts of functionalities in your application that you really should test in isolation and not depending on one another. What's the problem with that long test? Well, how about if the login breaks? You never really get to test if the checkout works, because you never get past the login, you are never able to add items to your cart, and you never get to really test anything but the login that just broke. The ideal solution would be to have just smaller tests that can plug into certain state of the application. Just test the specific functionality you're looking for, and then end. So you would probably have something like test login that will test your login. Then you would have another test that would be test add item to cart. The problem is that this test will need to log in. Well, if you have the specific handles to generate this state, you don't really have to go through the website to log in. You could generate something like self or magic login, and you specify the username. Let's call that username Sandy, just to make it more readable. So now this test add item to cart will not depend on the login anymore to work. It will just magically run this code and appear to have the session ready and be in the account page ready for you to add an item to the cart. So in the same way, if you have a test that will be test checkout cart, you will have some magic login, and then you would have magic add items, and you would provide probably a list of items that you want to add. Let's say that they're going to be number coded items. So I don't really need Selenium to go through all this workflow through the website every time I want to run a test. So I will first test that the login through the website works. This will probably write the username and password and try to hit the submit button and see if it works. Now the add item to cart is going to run this magic login. We don't really know what it's going to do. It may just insert the information in the database and give you a cookie to create, and Selenium would just do it. The big advantage is that if the login in the website broke, the magic login will still work, and you will still be able to add items to cart and keep testing the other functionalities in the application. Another huge advantage is that magic logins and magic generating states through the backend of the application takes generally way less time than logging in. In this case, the login will have to do something like open /login then type username, type Santi in the username field. Oh, I think it's the other way around. It's actually type, doesn't matter. So click submit, and then wait for page to load. You probably get the idea. This whole process, let's say that it takes around 30 or 40 seconds between the time the login page ends loading, then Selenium gets to type all these values, then clicks on the button, and then waits for the new page to load. Well, if you run this magic login that just inserts the information in the database and creates a cookie, this would probably take less than a second. Let's say a second. So your test will pass, this whole process will probably take 60 seconds. So now you will pass from having this same 60-second workflow inside your add test to card to something that takes only a second and gets you to the spot you want in the same, in a more robust way and less time. So generating application states is definitely the way to go. If you want to see an example of how to do it, I can show you how we do it at Sauce. We have both manual login and just login. The way we call login is, you can ignore this, but basically what we do is we get the username and we open this magic URL that we have only enabled in our development environment. That is saucelabs.com/test/login/ and the username you want. And that's it. That's everything you need to do, and the application will just log you in, and now you will have a session ready without having to type username, password, or anything. It creates the cookies in the browser for you, and that's basically it. So you change a process that takes around 90 seconds or 60 or whatever to something that is only opening a plain text URL that creates a cookie. I would say it probably takes less than 5 seconds. Still, if there's some part of the workflow in which you really want to log in, we still have a function called manual login, in which you can provide your username and password, and it will go through the regular workflow of going to /login, typing username in the username field, typing password in the password field, and submitting. So that's definitely a really useful advice. Make sure you can plug in some test handles to your application. And remember, keep these off when you deploy to production. There's different flags you can use or stuff. Probably your web developers, if you are a web developer, or your developers if you're not, will have ideas on how to do this. Now, another one that should already be well known, but just wanted to make sure that everyone does have this present. You should always wait for the right events to move on in Selenium land. I've seen a lot of users using static pauses. What are static pauses? Well, static pauses are things like once you open a page, you run a command. So in Python, it's going to be sleep 5. So users try to open this page, and when they get to type, sorry, this is actually in the inverter, so I'm going to fix it real quick. So when they try to type on the username field, they get a failure saying that the username field wasn't there. So what they generally do is just add a 5-second sleep, and things just start working out of the blue. Seems pretty magical, but it's so common out there. Well, one of the good ways to fix it would be to have implicit waits, which is what I just said. The type will try to run, the element will not be there, so Selenium will just retry again and again and again until it's there, or a 30-second or 90-second or whatever timeout is met. Another good way to avoid the whole failure is to be smart and figure out why the element is actually not there. You should understand how the application works to do that, but maybe the problem is that the element may not be there because it's generated through Ajax, or it may not be there because it's using a jQuery UI, which needs maybe half a second to complete rendering the whole thing. So what you would have to do would be something like wait for condition, and you would wait for some JavaScript condition, something like Ajax. I don't really remember how the name of this variable is, but it's so basically jQuery has this magical variable called Ajax. Let's call it Ajax request. I don't really remember the name, but it will keep a track of how many Ajax requests are being done. So if the application is still waiting for the server to send an answer, this value will be 1. If there's 2 answers on the line, it's going to be 2. But when it's 0, you know that there's nothing else to wait for, so that you can just move on. So just be smart, try to figure out why the element is not present when you get such failure. And then once you figure out what's the reason, just write the right wait for command. So that's another advice. Now, using verifications. Verifications are, let's start with what verifications are actually. So if you use Selenium or Selenium IDE, you probably have in the past, I hope you have, you may have seen that Selenium has all these commands that are magically generated, like assertions for stuff, waiting for stuff, wait for commands, and there's also going to be verify. So what's the difference between verify not visible and assert not visible? So the main difference between the two is that the verify command will detect that the element is visible or not visible, whatever. It will detect that there's a failure, but the whole test will move on, and you will just proceed to the next action. Whereas the assert command will just stop the whole execution and say, hey, something is wrong here, I'm not going to keep running. So I don't really see the point in using verifications when you do such thing. I think that the ideal test case is really short and is aimed to test only one functionality in only one application. So my advice would be never write verifications. Just write the asserts that you need, assert for just the stuff that you're interested in your test, and you're gonna be good. Writing verifications it's just gonna be confusing when you see test results, that you see that there's like 5 things that worked, there's 5 things that didn't work because the Selenium detected something wrong and moved on, but you can never go back and see why it actually failed. So just write assertions, get the failures right away, and start working on fixing them as soon as you can. If your tests are short, you're not gonna miss much. Now, this one is pretty sad, but it actually gave us, it actually worked out really well for us. Basically, we are ignoring Selenium failures for open and wait for page to load commands. I'm not going to say this happens really often, but even if it happens in less than 10% of times, it's going to break a lot of builds if you trust in your build a lot and you want to keep it green. You definitely want those to go away. The thing is that depending on the browser that Selenium is driving, sometimes an open command or wait for a page to load will fail to complete. That could be because a static asset is not loaded, or some CSS file wasn't available in the server, or who knows. It depends on the browser. You will notice this a lot in IE, even more so IE 6 and 7. Just out of the blue, the open command will time out or will give you some random failure. The good thing is that when you go to Sauce Labs and see the video of the execution, you will see that even though the open command failed, the page was ready for you to start using. This could even happen in real life. Maybe you have a user that opens your web page. They're not really going to be waiting for the status bar to complete loading. When they just see the part of the UI that they're interested in, they will just click around and keep on going. So you should actually do the same thing for Selenium. So if you have a test, let's just take our example again. Let me set the syntax to Python so it's pretty. There you go. So if you have an open command that every once in a while fails out of the blue, and when you just rerun it, it works, you could do something like try to call this open if it fails, except pass. So all you're doing is just trying to open the page. If it fails, just move on. Selenium will just try to find this element, and if it's present, the page is probably loaded anyways, so you don't really care if the open completed or not. All you care is about the functionality you want to test. And if the elements are present for you to use, that's probably good enough for you to know that everything's fine. So in Sauce Labs, if you want to see how we do it, we don't really have a try catch around every single open command in our website, in our test suite. So what we do is we just rewrite the open. So if you call open, we will try to run Selenium open, and if it fails, we ignore it. So transparently, all you need to do is just use open, and it will never return an exception. So let's keep moving on. All right, that's the basic list of things that I have for Selenium 1. Even though that was pretty quick, it's probably going to take you a while to implement all these. I'm going to make sure I write a blog post or I publish the video of this webinar so that everyone has this list and can think about it a little bit with a little bit more time and watch the examples with a little bit more time. Now, Selenium 2 tips. We also have a lot of Selenium 2 tests, and I have to say it's way more robust than Selenium 1. Actually, personally, I haven't written a Selenium 1 test in a while. All I do right now, every time I need to test a JavaScript part of our application, I mean part of saucelabs.com, I just write a Selenium 2 test and forget about the Selenium 1 problems that we had in the past. So for Selenium 2, again, implicit waits, they are the most awesome thing ever if you want to keep your build robust. The way you do it in Selenium 2 is way easier than Selenium 1. We have a Selenium 2 test case that does most of this stuff. And you can see that when we set up the test, we will run driver.implicitly-wait. We actually set this implicit wait to 5 seconds if you're in development and 30 if you're in testing mode. This is not that important. We just wanted developers to get faster results and we wanted our build to be super robust, so we just set this dynamically. But you could do the same thing by just setting this to plain 30 seconds. So every time the test is set, you get the 30-second implicit wait as part of your suite. Way easier than Selenium 1. There's no method to rewrite or anything. You just set that variable, and Selenium 2 will do the magic for you. Now, this is actually pretty handy. I'm going to write an example here too. Let's say that you want to add some item to the cart. So you want to do a click on a pretty special element. Let's say that you want to add the 10th item in the list. So you will do something like, let's say that it's a CSS locator. You could probably do, you should be able to do XPath too. But let's say that I'm going to do something like click on the item list. Oh, sorry. List, and this is going to be a div. So click on this div that is the item list div, and inside it click on the div that is an element, an item to buy. But I want to click on the 10th element in this list. So this is totally going to work in Selenium 1, and you are probably just expressing what you're trying to do inside the locator. But if the person that is reading your test doesn't really know CSS or XPath, they will be a little bit confused by what you're trying to say. They're going to be thinking, what is this guy trying to do? Just div item list. What is that nth child thing doing there? Now, if you write a Selenium 2 test, you have a lot more interaction with the elements available in the page. There's a lot more stuff. Of course, this is all in the middle of a script. There's a lot of setup that you gotta do to get the driver ready and stuff. But let's say what you could do in Selenium land would be something like driver.find elements by CSS selector. So you will be able to pull all the elements available using a CSS selector. So in this case, I'm going to do the same CSS selector, item list, div.item. And now you will do items equals this. So the driver, instead of just interacting with an element in a single action, will return you the whole list of items. So now you will get all the item divs that you wanted. And then you can do something like items sub10 dot click. And that's going to click on the 10th item in your list. I think this is way more readable than just writing a plain string that represents a locator that says the number of elements that you want to interact with, the name, the class, or whatever. It's even way more useful because you can do other cool stuff like for item in items, and then you can do item.text or whatever. You can just print the text of that item. So in this case, you notice that you're interacting with the list of items and not just acting over a single one. I really like the way Selenium 2 handles this in a more object-oriented point of view, way of acting instead of just modular functional clicks and types. So if you're moving to Selenium 2, definitely consider getting all the items that you want to interact with and then playing with that list on your code. If you're using Java, play with that list in Java. If you're using PHP or, well, not PHP yet, if you're using Python or Ruby, just try to play with that list in your code. It's going to be more readable for your users, for your testers, and it's going to make your life easier. Now, The last few tips I have, it's only for SaaS users. Basically, we have some functionality in SaaS on Demand that I think every user should be aware of. And let me show you some of those. What is reporting pass-fail status to SaaS Labs? Well, as you may know, SaaS on Demand is the server side of your execution when you're running remote WebDriver or when you're running Selenium 1. Your test will always run in your end. The script will always be in your own computer, and you will be the only one that will know whether it's a pass or a fail. It's something that happens at runtime. What Sauce on Demand will handle is only the commands that the browser needs to run for you. So the test will do something like browser.open this page, and Sauce Labs will only see the request for an open. It will open the page and return the result. Then you will do something like assert that the title in the page is Sauce Labs. So what Sauce on Demand will get in that point is only a request for the title of the page. The assertion is only happening in the script that is running in your end. So we don't really know if you were expecting that title to be Sauce Labs or if you were expecting it to not be Sauce Labs, and therefore we can't really guess if the test failed at that point or not. So what we've built is a way for users to report what's actually going on in your test, so that when we show you the results, we can actually include what happened. So if you go to here, tell us whether it's a pass or a fail. So all you need to do is just send pass equals true inside the different ways for annotating your jobs. There's two ways to do that. If you're using Selenium 1, you can run set context. So you can do something like selenium.setContext and then pass this magic string that we will later parse and detect. So we will do something like, okay, this guy is sending a message to us, and it says job results equal pass or job results equal fail, and we will display that accordingly when you go to your jobs page. So for example, if you go here, you will see that there's a failed instead of a finished, and there's a instead of an error or something. You will see passed and failed instead of finished and error and things like that. We will just be smarter about what happened in the test and show you those results when you go to your jobs page looking for a solution. And therefore you will be able to just filter those, so you can just click on the failed and you will get the list of failed jobs, or you will be able to click on the past and only see the past ones. So reporting pass fails is pretty handy, and it's now you're going to think, well, it's really painful to actually do this with a set command. Every time a test is over, I would have to report pass fail. Well, that's not the way to do it, actually. The way to do it is during the tear down of your test, you should be able to pull what's the status of the test and then report it before you call selenium.stop. So in Python, this is what we get. We just pull this magical property, this magical method that the test case has, which is called exe_info, and it will be known only if the test passed. So once we get that, all we do is just run selenium.setContext with that value. And then we kill the session and end the test. So there's no part in the test itself in which we are writing the set context call. It just happens automatically for every test case that we have during the tear down. I think that's the way to go. And once you implement it, it's just going to work every time, and you're probably going to be pretty happy about it. So keep it in mind. And one last thing, I notice a lot of our users are trying to test internal applications or are trying to test public applications that use resources that are only available internally. So using Sauce Connect 2 is definitely good advice. Let me show you what Sauce Connect 2 is. So Sauce Connect 2 is this small software that we created to tunnel all the network traffic from the browsers that you run in our cloud through a machine that you control. So if you need to hit an internal server, the browsers that you run in Sauce Labs will not be able to go through your firewall to find that server. But if you run Sauce Connect inside your own LAN or inside your this internal infrastructure, the machine in which you run it will have access to the server. Therefore, all the information that goes through Sauce Connect will just end up in that machine without any efforts at all. So all you need to run is something like this, which is going to be the command to start Sauce Connect. In this case, ouch, I'm showing you my access key. I'm going to have to remove this later. It's going to be customized to every user if you're logged in. But all you need to do is just, let me show you, download Sauce Connect to your own machine. I actually have it. I'm not going to download it. But once you download it and extract the zip, so if I do something like java-jar sauceconnect.jar, my username and my key, this will just start this mini service that will keep running all the time, that is tunneling information. As you can see, it starts a special machine for you in our infrastructure. It waits for it to boot, and then it creates a tunnel through that machine and yours. And now all the traffic goes through my machine. So for example, if you need to test an application and access it from a server in, let's say, England or Europe, you can always just start Sauce Connect 2 in a machine in Europe, and all our traffic, even though our servers are in the US, they will all go through the tunnel to Europe and go out of there from that machine. Your web servers will always see the IP coming as the machine that runs Sauce Connect, and not the IP as the browser in our cloud. So that's pretty handy. And again, if you need to access a server that is only available inside your private network, just start Sauce Connect in a machine inside that private network, and that's all you need to do. Again, now I'm successfully connected, so every test I run will go through this tunnel. If you need to shut the tunnel off, all you need to do is just hit Ctrl+C, and you will see that the tunnel is shutting down, and that will kill the connection. Now you're secure. Nothing else will go through the tunnel from now on. So it's something you control. The content is totally encrypted, so it's pretty secure. And I think that's basically all the list of things I had to cover. Now let's see if you guys have any questions. You can always just write it in the chat. Or even better, if you want to just ask a question, I can just unmute you. If you have mic, we could totally do that. I think you can raise your hand or just let me know over the chat, and I will open up for you. So it seems like no one has any questions. That's pretty awesome. It either means that I've been super clear or that I wasn't clear enough. I hope it was the first. We're gonna be sharing a video of this webinar in our blog. So if you want to just wait until there and then write your questions in the comments, I'd be super happy to read those and answer them. as they come up. All right, guys. Thanks for being there. I'll see you in another webinar. Bye-bye. Oh, sorry. So I saw a question there right before it was over. Can you show me some new features in Selenium 2? Well, that's kind of a pretty broad question. Let me think about it. I can, without making this webinar really long, going through all the list of things that Selenium 2 has. Probably the places you want to go is selenium.hq.org/docs. I'm actually part of the documentation team. I help writing some of these pages. So I know that you can find Selenium 2 information here. So if you go to the documentation, there's 2 complete chapters about Selenium 2. One is called Selenium 2 on WebDriver, and the other one is called WebDriver Advanced Usage. I definitely encourage you to start with the first one. So if you click there, you will find cool stuff like Selenium 2.0 features that will list all the features available. It will also show you real code, examples of how to write Selenium 2 tests. I think the main feature of Selenium 2 is its super slick API. Most of you, I mean, all of you that use Selenium for a while probably know by now that the API is insane. There's all these commands, there's all these duplicated things like get value, get text, and things that are confusing. And for a single person to understand all these APIs and learn all the different methods available, it takes a while. Now, if you move on to Selenium 2, you can be sure that it's not going to be as painful as it is with Selenium 1. There's only a few methods available for things, so that you can just run driver.findElement and you will get an element itself. That element will actually have definitely not as many as Selenium 1 commands that you could use, like send keys, submit, click, or get text, or things like that. Definitely check it out. The API is worth it for sure. Oh, interesting. So you're asking, what about dealing with alerts, confirmation dialogues, and download files? So if you're asking about Selenium 2, there's an API for most of these, interacting with alerts, getting the value of a confirmation dialogue. I have to tell you that in some browsers you may have problems using them because the project is still catching up, but I could be wrong, and all of them could have been already implemented by now. Downloading files, same thing. The browser will not lose you will not lose control of the browser as it happened with Selenium 1, because Selenium 2 is JavaScript based, but it drives the browser at a different level, so it can still get full control of the browser even though the confirmation dialog has been up, and use a special mechanism to shut up that dialog or remove it or accept it or whatever you want to do in your test. So if you have to deal with this stuff, definitely move forward to Selenium 2. You can check out the full API. Let me see if I can find Selenium 2 API. It's probably inside Google Code and not Selenium HQ. So yeah, I would have to Google it for a little bit. I think I found it now. Yeah. So it's inside Google Code, and if you explore the whole SVN trunk, you'll find that there's a docs/API folder, and you can find them there. I'm gonna see if we can include links to this in the documentation. Maybe they are, I don't really remember, but you will find all the different methods available inside for Selenium 2 tests right there. So you can find things like finds by class name, well, find element by class name actually. All this click type and things that you need to learn when you want to write tests. And we should probably write some blog posts about Selenium 2 and maybe do a webinar for users to start catching up with it. I have to tell you my experience by being a Selenium 2 user for over 2 or 3 years. When I moved to Selenium 2, I really loved that the API was so short, and I really loved that my tests worked right as soon as I just finished writing them. I was really amazed that they just worked, and they were as robust as the Selenium ones, and without all the extra code that we needed to write to ignore all these failures or retry when things are not there. Selenium 2 just does this stuff for you, and it's super handy. So I definitely advise you to just start writing some tests, check it out, and you don't really have to move all your tests to it to try it out. You can just start writing new ones with Selenium 2 and keep the old ones in Selenium 1. There's no real reason for which you can't have different frameworks for all your tests. That's what we do at Sauce, and we haven't had any issues. So I hope you enjoyed the webinar, and I hope to see you soon in a new one. Thanks for joining.